HERS verification of existing features. The reference used for this training is the HERS Technical Manual Appendix A. It can be found at the Energy Commission's website at the link seen here, or you can download it from the training platform. All the information relating to HERS verification of existing features is found in Appendix A. You don't want to look in the reference appendices like you do for a lot of the other HERS measures. So this one is unique to the HERS Technical Manual. When adding to or altering an existing home, compliance credit can be taken for upgrading existing features by using the performance approach when the existing features are verified by a qualified HERS rater prior to registration of the Certificate of Compliance. Third-party verification of the features prior to the construction is required to receive this compliance credit. The credit level depends on whether defaults are used or actual values that are less efficient than defaults collected by the HERS rater. So what happens here is the Title 24 consultant that is going to be modeling this project, they find out from the general contractor, the homeowner, that various values for features of the home are less efficient than the defaults that exist in the tables that the Title 24 consultant would use to generally model those, insulation values, window values, things along that nature. So what the Title 24 consultant will do is they will model those less efficient values. The HERS rater will then go out and verify that those less efficient values actually exist. And then when they do, that CF1R is allowed to be registered, showing those less efficient values, which in turn results in more credit available to the Title 24 consultant to get that house into compliance. The overall training goal is to gain an understanding of existing conditions and the verification process.
These are the sections that we're going to be covering in this PowerPoint. So for the HERS inspection process, the HERS rater can verify the existing conditions before or after the compliance run is actually completed by the Title 24 analyst. However, the HERS rater must visit the home to verify the assumptions of the existing conditions of the building prior to registration of the Certificate of Compliance, which is the CF1R. The data registry will then generate a CF3R EXC20 compliance document based on the output from the performance compliance software. If conducting the inspections prior to the compliance run being run, the rater will be informed of what building components will be updated. The rater or builder then determines what products are installed in those areas and informs the energy consultant of their findings. After the energy consultant inputs the correct values on the CF1R, the rater verifies the conditions on the CF3R EXC20. At that point, the Certificate of Compliance can be registered. So all that has to happen before the CF1R is actually uploaded and registered into the registry. The generated CF3R EXC20 will list the features of the existing conditions that must be field verified by the HERS rater. A registered CF3R EXC20 that agrees with the existing conditions input for the proposed building for the performance compliance calculation will be required by the HERS registry as a prerequisite to completion of the registration of the CF1R for the project. HERS raters are to follow the protocols for a whole house ohm energy rating, which is a HERS2, when verifying existing conditions. However, the requirements of following HERS2 or WHHER protocols does not mean being whole house rater certified. So a rater will use the same protocols, however, they don't have to be HERS2 certified to perform these particular verifications. The following are the potential pre-existing components that will have to be verified by the HERS raters for the purpose of these inspections. You have the building envelope, that includes walls, floors, and ceiling construction, fenestration, water heating systems, space heating cooling equipment, and air distribution systems. So first of all, as far as the construction goes, you want to determine the framing type, 2x4, 2x6, is it wood, steel, SIPs, ICPF, logs, or any other type of construction. You want to determine the insulation R value. Now, ideally, if you can find the actual R value based on what's on the actual insulation, or if you have documentation to show what it is, that's great. You definitely want to do that. If for some reason you cannot find any specific values, then you can use these values based on the type of insulation that's being installed, whether it's fiberglass, loose fill, vermiculite, whatever it may be. So just apply this R value per inch based on the material that you're seeing being installed. And again, if the bad insulation is installed that you can read the R value straight off of it, you can do that as well. If unable to verify the R value of any building component, Vintage Table R3-50 from Appendix B of the Residential Compliance Manual must be used. And this is the table in question that I just mentioned a second ago. So if you really cannot find the value that you're looking for, you can use this vintage table to come up with some kind of approximation of what the value will be based on the age of the home. Now, one thing you want to keep in mind is the fact that this particular table is giving you U factors. So you have to convert it to R value, just like we had talked about earlier in the Title 24 overview and the principle of building science. And this is the same formula. So you'll need to convert the U factors to R values as described in the basic building science section that I just mentioned a second ago. So the R value is the inverted U factor. So R value equals 1 divided by the U factor. So if the U factor is 0.356, to find the R value, you're going to divide 1 by 0.356. That's going to give you an R value of 2.8. In order to determine the R value, you want to look whatever it is that you can. So you want to check a plumbing outlet under the sink. In order of preference, remove cable outlet plates, telephone plates, electrical switch plates, or electrical outlet plates on the exterior wall. So basically anything that you can remove without being destructive about it to kind of figure out the type of insulation you have in the walls, you definitely want to do that. You can probe the cavity around the exposed plate with a non-metal device, such as a plastic crochet hook or wooden skewer, to determine the type of insulation: fiberglass, cellulose, insulation, foam, whatever it may be. And then you can inspect the outlets and switch plates on each side of the house to verify that all walls are actually insulated. If you have foam core walls or SIPs, the value is chosen based on the insulation level of the core. Values are presented for both EPS, which is expanded polystyrene panels, and Polizio panels, which is polyisocyanurate. Assume an insulation R value per inch of 3.85 for EPS. For Poliso core panels, the insulation R values R26 and R40 are present for 4.5 inches and 6.5 inches panels, respectively. For log walls, select a U factor based on the log thickness from table 4.3.11 of reference appendix JA4 and convert it to R value as previously described. And this is the table that I just mentioned. Insulated sheathing may exist on walls but can be difficult to verify. Walls with insulated sheathing may be thicker than walls without insulated sheathing. Visual verification of insulated sheathing may be found in the attic at the top of the wall, exterior wall penetrations, and at the connection between the foundation and the wall. You want to determine the thickness of the sheathing and the resulting R value. The ring joist is installed around the perimeter of the floor joist over a basement or crawl space or between two stories of a house. From the basement or crawl space, you want to visually identify and measure the depth of insulation at the rim joist. The insulation used is generally fiberglass batts, often folded in an L shape and attached to the rim joist. Rigid board insulation may also be found. Look for access to the rim joist area between stories from a garage or a utility access trapdoor. You want to visually identify and measure the insulation if it exists. If no access can be found, assume insulation exists at the rim joist between stories if insulation was found at the rim joist at the top of the crawl space or basement in the same house. Otherwise, assume no rim joist insulation exists. Now, for determining wall orientation, you want to use a set of plans or a compass to determine the azimuth and the orientation. For floor installation R value, for loose fill applications, multiply the thickness of the insulation in inches by the R value per inch based on the insulation type in order to calculate the total existing floor insulation R value. So the list of R values per inch based on the material of insulation that you saw at the beginning of the wall insulation section, you can use those same values for the floor insulations, attic insulation, whatever it may be. You can use those repeatedly for all types of insulation. Also note if any exterior sheathing insulation exists as well, and then determine if the slab insulation is present. You want to determine the type of ceiling insulation present, maybe a combination of more than one type, so you could have bats in certain areas, blown in others, whatever it may be. You want to measure the depth of the insulation in 4 places and take the average. If the depth in one section of the attic is different by 2 inches or more than other areas, measure the depth for the area separately or use the least depth for the whole attic. You then multiply the R value per inch of the material by the depth of the insulation. You want to determine the roof rise. Using a set of plans or a digital level, determine the roof rise. If it's 212 or less, it's considered a low slope. If it's more than 212, it's a high slope. You'll determine roof products. You want to identify the type of roofing surface that's being installed. You can choose from concrete or clay tile, metal tile, wood shakes, other high slope roofing types, that's including asphalt and composite shingles and tapered cedar shingles, or low slope membranes, which is usually found on a rise to run ratio of 212 or less. You want to determine the emittance and the reflectance of material types. For radiant barrier, you just want to verify that the installation is in accordance with the standards, which is below the roof deck, and all gable end walls also have to be wrapped in radiant barrier, just like we had talked about in the Title 24 overview. Now you will move into determining fenestration. So for area, you want to measure the area of the openings using width times height to the nearest inch. You can estimate the width and height to represent the rough frame opening. Typically, this will be outside dimensions of the frame plus an approximate half-inch perimeter band. After you found out the area of the windows, you want to verify the orientation of the windows by using a compass, adjusting for magnetic deviation, to determine orientation of all fenestration. If a partial map or a site plan is available, orientation may be determined just by looking at the plans. Also, specify the tilt for the windows that are not vertical. Frame type, you want to examine each frame in order to determine the type of material that's being used for the window, whether it's metal, wood, vinyl, fiberglass, whatever it may be. Ask the customer for documentation if you can't tell. You will also want to look at any kind of glazing characteristics the fenestration may have. You want to check all windows in the house for number of panes, single, double, glass block, whatever it may be, and the existence of any tint that you might be able to see. And then you want to determine the window type, whether it's operable, fixed, it's a greenhouse garden window, skylight, whatever it may be. Solar gain coefficient, so you want to check for labels if available, or you can check the product information and consult the NFRC guide. If the NFRC product information is not available, you want to select a representative solar gain coefficient from table 110-6B of the Title 24 standards based on the number of panes and the existence of a tint or film. And that's the table that we just mentioned a second ago. So simply based on the frame type, the type of window that it is, and the type of glazing, you can retrieve a solar gain coefficient value to use for the purpose of these verifications if you cannot find actual values. For the U factor is the same thing. Again, you want to check for labels, you want to check product information and consult the NFRC guide. And if an NFRC product information is not available, you want to select a representative U factor from table 110-0.6-A of the Title 24 standards based on the number of panes and frame type. And this table looks just like the other one, except that it's specific to U factors and not solar gain coefficients. For skylights, you definitely want to define the area of the skylight. So for skylights with a curb, measure the length and width of the skylight to the outside dimensions of the curb. For skylights without a curb, you want to estimate the dimensions of the rough frame opening. Orientation of skylights, just like you did for the regular windows, you want to determine the orientation of the lower edge of the skylight. Use the outward horizontal direction perpendicular to the lower edge of the skylight as the orientation of the skylight. You want to measure the tilt of the skylight relative to the horizontal, and this can be done with a level or angle finder instrument or geometrically with a protractor, or assume the same tilt as the pitch of the roof where the skylight is installed. And you can find that on the plans as well. For exterior shading, you want to verify any exterior shading device permanently fixed to the house present. You want to measure the dimensions of overhangs and fins. Storage water heaters. You want to determine the tank volume in gallons, exterior insulation, BTU input rating, and energy factor by examining the water heater's nameplate and product literature. If the energy factor cannot be determined in this manner, use the model number to find the energy factor from the CC Appliance Directory or Manufacturer Trade Association directories. If for some reason the energy factor cannot be determined from the FTC label or from the model number and manufacturer's information, you want to use the equations below to determine the energy factor for the storage water heater. So the formula is the same, but numbers change for the gas and electric water heaters, and those are simple formulas that you follow. So for gas water heaters, the formula is 0.62 minus 0.0019 times the volume, and then for electric water heaters is 0.93 minus 0.00132 times the volume. V is the volume of water heater in gallons. For older water heaters, meaning manufacturers before 2004, which are wrapped in R12 insulation or better, add 0.05 to the energy factor. For large storage gas water heaters not covered by NACA greater than 75,000 BTUs per hour input, look for an efficiency rating on the water heater and the tank R value, the total thermal resistance of internally insulated tank, and the R value of any external insulation wrap. The standby loss is taken from the Energy Commission database. For combined hydronic heating systems, determine the heat input in kBTUs per hour for gas, or kW for electric, and the recovery efficiency percentage. For large storage gas or indirect water heaters in a combined hydronic heating system, determine the pump input in watts. For For large instantaneous water heaters, more than 10 gallons, determine the unit's thermal efficiency from the nameplate or by using the model number, NCC, or manufacturer's directories. For gas models, determine if there is a standing pilot light. Determine the pilot light energy consumption in BTUs per hour from the Energy Commission's database. Also, record the standby loss in BTUs per hour and note the R value of any external insulation wrap. For small instantaneous water heaters, determine the energy factor of the water heater. If unable to find the energy factor, you may use vintage table R3-50 from Appendix B of the Residential Compliance Manual, which you're seeing below right here. So again, just like you use the same type of table for the insulation, you can do the same thing for the energy factor if you cannot get it anywhere else. Just base the number on the age of the house, and you're good to go. Determine the water heating distribution system type used, as previously described in the water heating section. When determining heating and cooling efficiency values for heating, you want to identify the type and model number from the nameplate and review CC appliance directories or historical gamma product directories to determine the efficiency. If the efficiency cannot be found, use the default value from table R3-50 of Appendix B of the Residential Compliance Manual based on the estimated age of the equipment. And that's the table that I just mentioned a second ago. AFUE is used to measure the efficiency of furnaces and boilers. HSPF is used to measure the heating performance of heat pumps. If a HSPF rating is not available, look for a COP rating and use equation R3-32 in the Residential ACM Manual to convert it to HSPF. This is equation R3-32 that was just mentioned. So the formula for the HSPF is 3.2 times the COP minus 2.4. In the example provided, the COP is 4. So the formula will be 3.2 times 4 minus 2.4, which gives us an HSPF final of 10.4. For cooling, you want to check the nameplate for the type and model number and use this number to determine the efficiency from CC appliance directories or ARI directories. EUR verification protocols are the same as previously described in the new construction section. If the efficiency cannot be determined, use default value from table R3-50 of Appendix B of the Residential Compliance Manual based on the estimated age of the equipment, just like you did for heating. And this is the table specific to the cooling. When determining air distribution systems and duct insulation in particular, air ducts may be insulated with insulation blankets or rigid insulation board. Inspect the duct or pipe insulation for R value labeling, usually printed on the insulation by the manufacturer. If the insulation is not marked with the R value, identify type and measure the thickness of the insulation to determine the R value. Also, check for internal insulation by tapping on the exterior and listening to the sound. For ducts buried in attic insulation, effective insulation R values shall be taken from table R3-38 of the Residential ACM Manual. The portion of duct runs directly on or within 3.5 inches of the ceiling gypsum board and surrounded within blown attic insulation of R30 or greater may take credit for increased effective duct insulation as shown in table R3-38. And that's the table specific to duct insulation.
Ducts partly or completely buried in blown attic insulation in dwelling units meeting the requirements for high insulation quality, Residential Appendix RA3-2013, Section 3.5, and procedures for field verification and diagnostic testing of air distribution systems, Residential Appendix RA3-2013, Section 3.1, may take credit for increased effective duct insulation. For each duct segment buried in attic insulation, indicate the duct diameter, attic insulation value, and insulation type, whether it's fiberglass or cellulose.
Deeply buried ducts may take credit for an effective R25 for fiberglass and R31 for cellulose insulation when residential ACM requirements are met. And now we'll mention the forms that are specific to additions and alterations. And then you have the CF3R EXC20, which is the form that you would outline the existing conditions for residential applications, which is everything that we just talked about in the previous section. As usual, if you have any questions, give us a call, shoot us an email, or send us a message through the LMS messaging system.